Hi everyone, welcome back to our channel. So today we are going to solve this problem number 45. Find the current through the load resistor of 1 ohm using Milliman's theorem. So let's try to do with this by method 1, and method 2 we'll try to do without the Milliman's theorem. Okay, that also will do it. So see here, so a little bit this is confusing. So actually we have to convert this into an voltage source for our convenient. So I'm going to apply source transformation here, and I'm going to apply source transformation to this network. If you apply source transformation, let us assume this has some node 1 and this has some node 0. Okay, so now let's try to mark this is node 1, node and all are connected in parallel, automatically node 1. Okay, so between 1 and 0, let's try to identify the elements. Okay, so what are the elements that are connected between 1 and 0? So you are having an resistor and the current is moving up, automatically this will be a positive terminal and this will be a negative terminal. So V is equal to I into R. I is 5 into R is how much? 2. So 5 2s are 10 volts. And what is the resistance? Here it is connected in parallel, this will be in series. Okay, and next this is node 1. So next you are going to have one more conversion of practical current source into an voltage source. What is the value of this resistor? 2 ohm. What is the value of this? V is equal to I into R. I is how much? 3. R is how much? 2. 3 2s are 6 volts. And now the resultant load resistor we are going to replace. Okay. So this is nothing but RL is equal to 1 ohm, and this is nothing but the current IL. Okay, we need to find out. So now let's try to see the formula of applying. So we need to convert, this is an electrical circuit 1, this is an electrical circuit 2. Let us try to convert this into an single equivalent. So this is nothing but a single equivalent Millman's theorem equivalent. Okay, so single Millman's equivalent circuit consisting of an equivalent voltage and R equivalent, and replace the load resistor where this is nothing but RL. Given in the problem is how much? 1 ohm, and we need to find out the current IL. So how to find the current IL? The IL is the current flows in R equivalent and RL. Therefore IL is equal to V equivalent minus 0 divided by R equivalent plus RL. Why? Because the current is flowing from here. Try to apply the current I equal to V by R. Okay, current is leaving is plus V equivalent and it is flows. I can say now these two are again connected in series. So this is the resultant formula. Now we need to find out V equivalent. V equivalent is equal to the formula. We are writing it as let's try to mark this V1 and V2. So the current I'm taking as in this direction. Okay, so when I take the current in this direction, so I can write down this as V1 into 1 by R1. Okay, so current also in this direction plus V2 into 1 by R2. Okay, so 1 by R1 is nothing but conductance. 1 by R2 is also conductance divided by 1 by R1 plus 1 by R2. Therefore, this we can write on it as V1. What is the value of V1? We have done it is 10 into what is the value of R? 1 by 2. Okay, plus, and current is flowing. What is the leaving polarity of this voltage? So 6 into R is nothing but how much? 1 by 2 divided by R. 1 by R1 is how much? 1 by 2 plus 1 by R2 is how much? 1 by 2. So just use your calculator, simplify it, then you are going to get V equivalent is equal to how much? 8 volts. And next we need to find out R equivalent. Okay, so the formula for we are going to have is 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So that is equal to 1 by R1 value is how much? 2. 1 by R2 value is how much? 2. It's nothing but 0.5 plus 0.5, where this is the answer of 1 by R equivalent. Therefore, R equivalent is also is equal to 1 ohm. Okay, so the value of R equivalent is 1 ohm. Just substitute here. So yeah, V equivalent is equal to 8 minus 0 divided by R equivalent is 1 and load is also 1. 8 by 2 is equal to 4 amperes is the amount of current flowing across the load resistor. RL is equal to 1 ohm by using Milliman's theorem. Same. Let's try to verify. Why don't we do by regular method? Sometimes we'll get this answer in the exam. You get confused whether my answer is correct or not. Okay. Now let's try to verify the same by using our nodal analysis. Okay. I'm redrawing the same network after source transformation. I'm redrawing my network. Okay. See here. This is a redrawn network. So for more clarification, I am assuming this as node Vx and this also this node 1 as Vx. Okay, so now let's try to redraw it, then you can understand better. Okay, this is 2 ohm. I have an voltage source. This is a one more branch, and here we require the current, and RL given is 1 ohm, and we require this current which is nothing but IL. So this is of 10 volts, this is of 2 ohm, this is of 2 ohm, this is of 6 volts. So now in order to apply nodal analysis, this is only the one node available here. So let's try to mark this node as Vx0. Vx, this node are connected in parallel, therefore the same node will be maintained 0, and this is 0. Okay, so now I want to find the value of Vx. That's why I am assuming the current which flows through this element I am marking as I1, through this element I am marking as I2, through this element I am marking as IL. So now let us try to solve this problem. This is nothing but apply nodal analysis is indirectly apply Kirchhoff's current law at which node we require the voltage at Vx. Okay, so now when you apply here, you can see here all these three currents I1, I2, IL all are leaving. There is no entering current. Therefore, 0 is equal to I1 plus I2 plus IL. Therefore, 0 is equal to, how to write down the current which is flowing in this branch? So voltage here is plus Vx, Vx, and next one here it is how much? Minus 10 divided by R. What is the value of R? 2. So how to write down the current which is flowing in this branch? So here it is Vx, and what is the leaving terminal? Minus 6 divided by R. R value is how much? 2 plus IL. So how to write down the current which is flowing in this branch? I can write down this as Vx minus 0 divided by 1. So segregate the constant terms and Vx terms separately. Therefore, 0 is equal to Vx by 2 minus 5 plus Vx by 2 minus 3 plus Vx. Okay, so this is nothing but 5 plus 3 is equal to, and we are taking Vx as an common term, which is 1 by 2 plus 1 by 2 plus 1. So use your calculator, then we can find the value of Vx. Therefore, Vx is equal to, we are going to get it as 4 volts. Just use your calculator, you'll get the same. But what I require is the IL value. What is the value of IL? As already done. So the current IL is equal to the voltage. So we successfully find the voltage of Vx is 4 volts. IL is equal to Vx minus 0 by 1. So which is nothing but 4 volts minus 0 by 1 ohm. This is the amount of current. 4 amperes. You can verify with the previous answer also. So we had also got the same 4. Okay, so you see here, so by method 1 we had got how much amount of current? 4 amperes. That's nothing but directly by using Millman's theorem. By using Millman's theorem we had got the same answer. Okay, by using our regular nodal analysis also we had got, but you are not supposed to do, you can verify your answer by method 2 also, whether your answer is correct or not. Okay, so to be frank, if you become expert, only this equation is sufficient. We have solved the problem only by one equation. Okay, so that's what the importance of this method of nodal analysis. But in particular, if the question is asked by Millmans, definitely you should use this method. Hope you are able to understand. So If you feel my content is useful, please like the video and share with your friends those who are studying the same subjects. And if you have any doubts, let me know in the comment section. I can answer your comments. If you're watching the channel for the first time, subscribe to the channel with the name KV Tulasiram. So kindly encourage these type of free channels for the development of students and faculty. Thank you for your support. Thank you for watching patiently. We'll meet in the next video. Viewers,